air resistant.
Okay. So air resistance is negligible. Sorry, air resistance is when you have an object falling. You have an object falling, and there is air moving against it. So the air moving against the object is air resistance. When the object is moving, it's falling, right? There is a point where air resistance and gravity match each other, right? That point is called free fall. Okay. In the air, a coin falls faster than a small piece of paper due to air resistance. This is determined by density and surface area. In a vacuum, both fall at the same rate because they're only being acted on by gravity. In a vacuum, there is no air, so there is no air resistance. Yes? So air resistance has a greater effect on light bodies compared to heavy bodies. Air resistance is negligible for dense, heavy objects at low speeds. Okay. So if an object is very heavy and it's very dense and it's not even falling a lot of distance, so air resistance will be negligible. The force generated by air resistance would be negligible. Okay. Now, acceleration of free fall. Acceleration of free fall. All bodies falling freely under gravity accelerate uniformly if air resistance is negligible. So, what is the uniform acceleration? It's called G. This is the force of gravity or the acceleration due to free fall. Right? It's called G, which is taken as 9.8. Right? The velocity of a free falling body increases by 9.8 meters per second every second. Make sense?
Yes, sir.
Okay. So an object that has been falling for 3 seconds would be traveling at 3 into 9.8 meters per second square, which would be how much? 29.4 meters per second, which would be its speed, right? After 3 seconds. So a ball shot upwards with a velocity of 30 meters per second decelerates by about 9.8 meters per second, reaching its highest point after 3 seconds. So it's saying that a ball was moving upwards and it decelerated. So the action of gravity was against it, right? And it reached zero
Yeah.
speed. Sorry, sorry. Any questions?
Not yet.
Okay. So it reaches zero speed after 3 seconds, right?
Yeah.
As an object falls, air resistance increases, reducing its acceleration. When the air resistance is equal to the object's weight, it falls at terminal velocity. What is terminal velocity? Terminal velocity is
Direction.
when the air resistance is equal to weight. Okay.
Yeah.
Terminal velocity depends on the object's size, shape, and weight. Okay. A small, dense object has a high terminal velocity and accelerates for a longer distance. Does that make sense?
Yes, sir.
right? So it's small, it's dense, it has a high terminal velocity. Why? Because the air resistance on it is very low and its rate is very low, right? So it will accelerate much longer. Okay. A light object or one with a large surface area has more has more air resistance acting on it. For example, a raindrop or a parachute has a low terminal velocity and accelerates over a shorter distance. Okay. Following is the velocity time graph for a parachutist. So first he has speed increasing at a decreasing rate, and then he opens his parachute, right? So after that he has speed decreasing at a decreasing rate.
Decreasing.
Yeah, makes sense.
Yeah. Karthik, yeah.
And this point, can you appreciate that this line is flat? It's horizontal, right?
Yeah.
It's horizontal. Can you see that this is horizontal? Yeah.
Yes.
So it has reached terminal velocity. Okay.
Yeah.
So any questions about today's class? Right?
No,
So
sir.
going back to an overview, we started with distance time graphs, where the horizontal phase on a graph is zero speed, right? And increasing graph is increasing speed, decreasing graph is decreasing speed. And then we moved on to speed time graphs. Speed time graphs can we have area under the graph, which is distance. We have increasing graph, which is increasing acceleration. We have constant graph, horizontal graph, which is constant speed and zero acceleration, right? Then we have this graph, which shows decreasing acceleration. And then we have distance under the graph. We have the equations, right? S is equal to u plus v over 2 into t. We have v is equal to u plus at, right? And then we have terminal velocity. Any further questions about this?
No, sir.
Okay. We'll end class here. Love